I didn't get that.
I came when you're saying going to with
The line is breaking. You can send a message via the chat. So today we'll be looking at artificial satellite and remote sensing. And these are the intended learning outcomes. We'll try to describe the Earth in relation to the solar system, discuss the significance of the center of mass of the Earth-Moon system. We also define the Gaussian constant of gravitation and solve simple calculations involving idealized synchronous satellite in circular orbit. Now, so I said the solar system contains the following object. That is the sun and the 9 planets. You must have known the 9 planets, but people say that the Pluto, because of his size, is not regarded as a planet. So those planets and dwarfs like Pluto, the satellite, the comet, the meteors, the interplanetary medium. Those are the constituents of the solar system. Now, the Earth is one of the 8 planets in the solar system, and these 8 planets are Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. And I've said that Pluto is considered that has not been a planet because of its size. So the orbit of the Earth lies between the orbit of the Venus and the Mars. Definitely, it is in between Venus and what? And the Mars, to a good approximation. The orbit of the Earth is an ellipse of small eccentricity. So the shape of the Earth is not circular, but it's an ellipse with small eccentricity. The element of this orbit suffer changes due to the presence of the motion and motion of. He said it suffers changes to the presence of the moon and the other planets. I will not say that the moon is a natural satellite on the Earth. Indeed, it is the center of mass of the Earth. Moon system that revolves. Let me read that again. Say that the moon is a natural satellite of the Earth. Indeed, it is the center of mass of the Earth-Moon system that revolves around the sun. So the Earth-Moon system, the planet is moving, and the Earth as a planet is moving. Also, the moon and revolves around the sun. Victor Chukuk has joined us, right? Okay. What do I do? Tom said, Doja Godwin has left. So Or did you get what I was saying before when you joined?
Yes, sir, I'm with you, sir.
Okay, did you start from the beginning? Should I start all over again? Because I started with
No, sir, just go ahead, sir.
okay. So I said the moon is a natural orbit of the Earth. Indeed, it is the center of mass of the Earth move system that revolves around the sun, and it lies above 1,600 kilometers below the surface of the Earth, or above. This should be above the surface of the Earth. So now, let me change that. What do they mean by below? Below means that, okay, the surface of the Earth, okay, no, it's still correct, it should be above. Now, we now look at satellites in circular orbit. Now, the relationship between radius and orbital speed. Now, we said there are many satellites orbiting about the Earth. Some of these satellites move in approximately circular orbit. Such satellites are kept in circular orbit by the centripetal force. For a body to move in the circular orbit, it must have a centripetal force provided by gravity. To remain in circular orbit, the satellite must have a centripetal force F given by that is F equals to mv squared over r. You know, A equals to v squared over r. So the force is mass times acceleration. But we are talking about angular acceleration here. Now, so we say where m is the mass of the satellite, v is the speed of the satellite, r is the radius of the satellite, and me is the mass of the Earth. Since it is gravity alone that provides this centripetal force, it follows that F must be equal to the gravitational force of attraction between the Earth and this satellite. Now, we are saying that this F, so that is the gravity. You know, we said here that this centripetal force is provided by gravity. So the F here can be said to be a gravitational force, which in tune can be, we can relate it to Newton's law of universal gravitation, which states that the force of attraction between two masses, M1 and M2, and in this case, we're talking about mass of the Earth and mass of the satellite, is the product of their individual masses and the inverse of the distance of their distance apart. So what we have there, if you equate this equation here to this one, you have GMEM over R squared, then equals to MV squared over R squared. So if we do the proper mathematics, M will cancel M. So what we have here is, what will be left here will be 1R will cancel R. So if you make V the subject of formula, you have V to be square root of GME over R. Now, the implication of that is that if the satellite is to remain in circular orbit of radius r, its speed must be equal to the value of v. So if it's to remain in the circular orbit of a particular radius, you must calculate the escape velocity, which is this. Can you all hear me?
Yes, sir.
Okay.
Yes, I can hear you.
Yes, so where did I stop?
Come on here, I beg.
Sam Friday. Can you hear me?
I can hear you, sir.
So where did I stop? I just discovered that the network went off. I don't know where. I think it was Victor Chukuka that was following me. I guess I will just have to go back a little.
I think I think we follow you up to where you say mv square over r is equal to gmem over r square, which should equate a two side.
Okay, good. So let me go back to that side. Okay, so this place.
Exactly, sir.
Yes. So we can say this is the escape velocity, and the implication of this is that for if the satellite is to remain in a circular orbit of radius r, its speed must be equal to v. So the v must be calculated with that, what's it called? The velocity v. So this is a constant, gravitational constant. This is the mass of the Earth, and this is the radius of probably the Earth, as the case may be. So that is that about that. Now, I said there's a class activity that I want you to attend. The Hubble Space Telescope is a satellite orbiting at a height of about 596 kilometers above the surface of the Earth. What must be the orbital speed of the HST if it is to remain in circular orbit? Can you quickly do that? Can you quickly do that? Can you quickly solve that? And I'm very sure you are to apply this equation. We're asking for this. Now, the poster there is that you are given a height, but from the height, you can deduce the radius. The height can be likened to be the diameter. Is that also?
Yes.
So with that, you should be able to calculate the radius and get the value of the, or you should screenshot that, then you submit the answer on the group page.
Okay.
Kauta Okasha, you're just joining us.
Yes, sir. Good evening. I'm very sorry for coming late, sir.
So let's proceed. What did you say? Are you trying to make any comments? No.
Please, I didn't get the assignment.
Come. What's stopping from repairing?
Okay, look at it. It's on display now. Can you see that?
Yes, sir.
So let's do a screenshot and Kauta, have we done the screenshot as well?
Yes, I've already done that, sir.
Good. So let's go to the period of the satellite. The period of a satellite is the time required for the satellite to move around its orbit. It is the time taken for the satellite to complete one orbital revolution. Now, in all circular motion, the linear velocity and the angular velocity are related by the expression V equals to R omega. So V there is the linear velocity, the omega there equals to angular velocity. And omega is, if for those that are taking 207, we said yesterday that omega is 2 pi over t or 2 pi f. So if we substitute that into that equation, that's why the omega there, the v now become 2 pi r over t. Now, what we now did here was to make t the subject of formula, and all we say, please give me a minute.